This is the electric field practice class. We actually had one of the discussion class pretty earlier. This is the content of this chapter is extremely small, but there are some pretty intuitive problem to be solved. So that's why we are taking this solution class. Electric field strength is defined by a force per unit charge equals to F by Q. So there are three variables involved. If you know the value of any of the two, you can find out the third one, which goes without saying. This is the electric field strength for any type of field. Uniform field, non-uniform field, curved field, straight field, parallel field, doesn't matter. This is the basic definition of electric field strength. The unit is Newton per Coulomb. Special case, if we have a parallel field or an uniform field, which in this case is shown to be created using two metal plates having a voltage of V across them and a physical distance of D among them, between them, then among the in between space, within the in between space between the two metal plates, there will be an uniform electric field, which means we are going to have electric field lines. They're going to be parallel and they're going to be equidistant from each other. And in that case, and in this case exclusively, the electric field strength within any point of this electric field, important, any point, the electric field strength within any point of this electric field can be given by V by D, which means if you measure it over here, you're going to get this value. You're going to measure it over here, here, anywhere you go, you're going to get the same value that is given by V by D. If you wonder why this is same, here's the deal. If you try to visualize a small positive charge, because that's the typical thing that we use to explain stuffs using electric fields. If we use a small positive charge that is placed over here, let me just take out this picture and maybe I'll draw. So let's say, good. If I draw, and draw, now I can. Why isn't my home tablet on? Also, it doesn't have to be on for me to be able to use this. Good. So here's the deal. If we place a small positive charge, let's say somewhere over here, positive charge, this plate will be repelling this thing downwards and this plate will be attracting this thing downwards. Depending upon how far it is from each other plate, that force should be more or less. For example, if you place this positive charge, let me zoom in a little bit more. If you place this positive charge really close to the positive plate, then this repulsive force will be really strong, whereas the attractive force will be pretty weak. If you slowly bring it closer to the negative plate, the repulsive force will become weaker and the attractive force will become stronger. The way these two forces will always work in such a way, the mechanism or the equations are not shown to you in the AS level, which is going to be included in the A2 syllabus. The way these two forces work is that the amount of decrease of force that is going to get because of from the repulsion of the positive plate will be equally compensated by the attraction increase from the negative plate, and vice versa for a negative charge as well. So that's why within this space, anywhere that you measure within this space, the electric field strength in between these two plates, you're going to get the exact same value for the electric field strength, which means if you have Q charge placed anywhere within this point, in all of this position, that Q charge will experience the same force. If it is plus Q charge, it will experience force in the direction of the field lines. If it is minus Q charge, it will experience force in the opposite direction of the field lines. That's basically it. এটা হচ্ছে আমাদের exclusive case for the parallel field, for the uniform field. And then what we have over here is shown over here that have look, due to electric field, any charged particle experiences a force in a fixed direction. This is important. For experience a force in a fixed direction, this is something similar to like gravitational force. Weight of an object always works vertically downwards, irrespective of its motion or position. This can result projectile motion in a parabolic path. So here we are showing a scenario like this. Let's say we have an electric field produced by a positive plate and a negative plate, and we are shooting an electron over here. The moment the electron will enter this part, actually this electron will start to accelerate from the very instant it enters the electric field. So the acceleration should be from the very beginning. It's not supposed to be working from here. It should work from as it enters into the electric field. However, you can actually draw a couple more arrows on the left on your notes so that you are not confused by this drawing. I take this on my responsibility. Maybe I was not able to be very vocal about this drawing, so the student who wrote this was not very correct. But this force would start to work on this electron as it enters into the electric field. But as it travels, the direction of this force will always be parallel to the field lines. So this is somewhat similar to like a projectile motion. And that projectile motion type of mathematics that we've seen in our chapter 2, kinematics and momentum, that can be used over here for a different type of calculation, which I'm going to show you some examples for. And finally, over here, we can calculate this acceleration by this formula F equals to QE. So ma equals to QE, and then acceleration is given by QE by m, or QE divided by m, and E is in this case written as V by D. So these are the conversions that we can have. স্যার কথা কেটে কেটে আসতেছে আপনার মাঝে মাঝে কেন? আমি তো কোনো ডাউনলোড চালাইতেছি না, স্ট্রিম অফ করে দিলাম।
ঠিকই আসছে,
হ্যাঁ
ঠিকই আসছে।
আচ্ছা ঠিক আছে, আচ্ছা ওকে। সো এইটুকু হচ্ছে আমাদের অ্যাক্সিলারেশনটা ক্যালকুলেট করার মেকানিজম, এন্ড দেন উই ক্যান ইউজ দিস ক্যালকুলেশন টু গো থ্রু সাম প্যারাবোলিক মোশন or some projectile motion type formula. That's basically it for the electric field theoretical concept. Now, to be able to solve these problems, what I would like you to direct is towards the worksheet. So turn on the worksheet on the MCQ paper. Turn on the electric field MCQ paper, and I want you to attempt solving number 9 9.1. 9.1 টা এক নাম্বার থেকে অ্যাটেম্প্ট করতে থাকো। Try to be as fast as you can, but do understand the question, and if you get stuck, mark those. I'll come and solve it. I'll give you some time, 6 minutes to attempt some problems right now, and then I'll come back and solve it. Remember, there are only basically two formula over here. One is for any type of electric field strength equals to F by Q. Small q, capital Q, doesn't matter. For exclusively uniform electric field strength is given by voltage over distance. This has a unit of Newton per Coulomb. This is given by volts per meter. It just so happens these two units are exactly equal to each other. This unit conversion is sometimes asked in the question, so you might as well want to have a look at this one, that how does volt per meter is equal to Newton per Coulomb. So they are interconvertible units, so they are basically the same quantity. It's one of the homogeneity check that we do. And finally, the acceleration of a charged particle within an electric field will always work in the same direction, which can lead to some sort of parabolic motion, which is going to come later. But core equation হচ্ছে এই দুইটা ছাড়া আর কোনো ইকুয়েশন নাই electric field চ্যাপ্টারে. So this is not supposed to be very difficult. Give it a go. If you get stuck, I'll help. So I'll pause the recording for the time being and mute my channel for about 5 minutes, and I want you kids to try 9.1. Start. So one of our students asked for question number 7 help. Here it is. The diagram shows two parallel metal plates connected to a DC power supply through a resistor. There is an uniform electric field in the region between the plates. Which change would cause a decrease in the strength of the electric field? Decrease. So this is a parallel plate. So what we know is this equation equals to V by D. If we want to decrease the electric field, either to reduce the voltage or to increase the distance. So either of them can work, or simultaneously both of them can work. A small increase in the distance between the plates, this will definitely decrease the strength in the electric field. Okay, A is supposed to be the correct answer, but let's have a look at the other options. A small increase in the potential difference between the plates. If you increase V, then electric field strength will increase. A small increase in the value of the resistor. A small increase in the value of the resistor will not change the voltage across these two plates, because there is no current over here. This is basically like working like a capacitor or the open ends of a switch. Even if you increase the voltage over here, you'd still get the same amount of voltage in between these two plates. You are only going to get a reduced voltage if there is an actual measurable current. Then this component would do some voltage drop in terms of I into R, depending upon that current. And then the remaining voltage will be available across the plates. Since there is no current happening because the two plates are disconnected from each other, they are working like sort of like two plates of capacitor. So all the supply voltage would be available across these two open ends. So the value of the resistor would not affect the voltage available across here. Whatever the source value, you're going to get the same value over here. বুঝছি কি বলছি?
Yes, sir.
And D is small equals to the area of the plate plus area doesn't matter. So disregard that. Anyone else? আর কোন দরকার?
স্যার,
জি
2 মিনিট সময় দেন শেষ করতে।
হ্যাঁ করো, সমস্যা নেই। You're using the recording 9.2 air question number 8.
Sir, 10.
Question number 10. Okay. One of the key properties for electric field lines is that they will always come out of a surface perpendicular to the surface. They'll also enter into a surface perpendicular to that surface. They will never make an angle with leaving surface or entering surface. It cannot be A or B, because you can see that these field lines are coming out of this curved surface circular charge at some angle, and they're also hitting this ground at some angle. That's not going to work out. They have to come out perpendicular. After coming out, they can take a curve, but at the at the very starting point, at the very location where they're coming out, if you draw a tangent of this curve, that tangent should be a perpendicular on that surface. This is a property of the electric field lines. মনে পড়ছে?
Yes, sir. জি।
Beautiful. So I'm gonna start 9.3 now. Are we good?
স্যার
বলা।
স্যার ওইখানে অপশন নাম্বার এ তে স্ফিয়ার থেকে যে ইয়াটা যাচ্ছে ওইগুলো তো পারপেন্ডিকুলার,
এখানে সবগুলো পারপেন্ডিকুলার না তো, এই তিনটা পারপেন্ডিকুলার,
নিচেগুলো না সেটাই।
নিচেগুলো তো না, but you have to have every field line coming out of a surface or entering into a surface to be perpendicular. For if you look at these as well, this one is perpendicular to coming to this over here. I mean, the problem is with these two and these two. The other four are okay, but there is mistake, so it's not acceptable. Okay. All right. 9.3 is actually pretty simple. There are a couple of things that you need to understand. There's just one specific interesting question, which is this one. I'm gonna discuss this in detail, but before I just pick this question, I'm gonna show you something else. Could I not copy this properly? Copy image, delete, Control V. Good. Okay. The first thing that you need to understand, that here's the deal. Point one. Equation is given by E equals to V over D. So for a fixed voltage supply, if you ever plot a graph of E versus D, of course, you're going to get an asymptote line on both axes, because it's an inverse proportionality. That is very simple. So that is basically asked in question number 1. If you have a look over here, two parallel conducting plates are connected to a battery. One plate is to the positive terminal and the other one is to the negative. The plate separation is gradually increased. The plates remaining connected to the battery. Which graph shows how the electric field strength E between the plates depend on the plate separation X? So in this case, X is the plate separation, or the distance between the plates. So if you increase the separation, the electric field strength is going to be exponentially decreasing. So obviously A is the correct answer choice. None of these other things actually make sense. Well, if in any case, just to give you a bit of an idea, you have to understand that in this case, E is proportional to 1 upon D. So if you have E versus D, you're going to get a inverse proportionality graph, or what can I say? We call it the inverse proportionality graph here, the negative exponential curve. However, if in any case you will see that the question gives us a graph of E versus 1 upon D, if they show us a graph like this, then this is supposed to be a straight line passing through the origin. এই দুটো জিনিস কি বুঝো সবাই? Do you understand the difference of these two things?
Yes, sir.
Okay, this was introduced to you in your O levels for the Boyle's law, PV equals to K. So if you ever plot P versus V, we're going to get like this. But if you plot P versus 1 by V, we're going to get like this. This was the information that you came across in your O levels. Same stuff. So this is one type of question. However, question number 35, this one is slightly different. Let's have a look at this question and have a read at it. Have a look. An electric field exists in the space between two charged metal plates. Which of the following graph shows the variation of electric field strength E with distance D x along the line xy? With distance D from x along the line xy. I want you to read this part of the question very carefully and try to make sense out of it. Read it slowly and carefully and try to make sense out of it. What does this phrase actually mean? What do you understand from it? D in this case is what? Is it the separation of the plates, or is it something else?
It's a distance from X. It's well, the plate separation remains constant.
Exactly, it's a distance from the X, which means if you can start, if you place a charge particle over here, this much is D. If you place a charge particle over here, this much is D. If you place a charged particle over here, this much is d. This is the distance of the charged particle from plate X. This is not the separation. They are using the same symbol that we have learned in our equation equals to v by d, but they have defined this d term not by the separation of the plates. They have defined the d as the distance of the charged particle from the plate X. Now remember, like I told you, that if we have a uniform field produced by two parallel plates, the electric field strength within this space will be same everywhere, and everywhere means everywhere. So no matter where you place this within this line, along this line, you're going to come up with the exact same value of electric field strength. Irrespective of the position of the charged particle, electric field strength value will not be different, because d in this case is the distance of the charged particle from the plate X. So obviously the correct answer will be C. No matter how far or how close, the electric field strength remains constant. Most common wrong choice is A, because students tend to think that, well, this is supposed to be a negative exponential curve. They don't read the question very carefully and directly go for this. Although, if you have a look over here, if you have a good mathematical mind, you wouldn't be able to give this as a correct choice, because you can see that this graph is not asymptotic on both axes. It is having an intercept on the y-axis. Inverse proportionality graph doesn't have intercept on any of the axes. They are asymptotic on both axes. So even by mathematical logic, this is not going to be answer, and by appropriate logic, this is going to be your answer. বুঝা গেছে কিনা? পোলাপান?
Yes, sir.
অলরাইট, এইটা ছাড়া এই পুরো পার্টের মধ্যে আর প্র্যাকটিক্যালি কোনো ডিফিকাল্ট কোশ্চেন নাই। তোমরা বাকিগুলো নিজেরা অ্যাটেম্প করো। বেশিরভাগগুলো হচ্ছে রিপিট কোশ্চেন। ইফ ইউ গেট স্টাক এনিওয়্যার, আইল হেল্প ইউ, আইল গিভ ইউ সাম টাইম এন্ড আইল পজ দ্য রেকর্ডিং রাইট নাও। In question number 6, it says that a positive charge experiences a force F when placed at point X in a uniform electric field. The charge is then moved from point X to point Y. Distances R and S are shown on the diagram. What is the change in potential energy of the charge? Potential energy change of the charge will be equal to the work done on the charge. And work done equation key. Remember, work done on an object is given by force in distance covered. This distance covered has to be in the same direction as the force. So if we apply some force over here, if an object covers it like this, we have to find out how much distance was covered in the direction of the force, and we have to multiply the force with this distance, not this distance, this one. Okay?
Yes, sir.
Now have a look. Which one do you think is the correct answer? Well, for that, I mean, you understand that the relevant value should be Fs. Now comes the question, should it increase or decrease? Okay?
Yes, sir.
Okay. Let me help you to understand another thing. Let's say here is Earth. Here is ground. An object is held over here. The weight of the object is working downwards. If we allow the object to fall downwards under the effect of weight, let's say it falls down to this position, what happens to the potential energy stored in the object?
GPE কমে যায় স্যার আর কে
Well, K কমতে পারে বাড়তে পারে, because I didn't say where the GP is going. It can also be converted into friction and stuff. But anyway, the GP will decrease for sure, which means when the system's available force is causing the movement, the potential energy will decrease. Vice versa, if we apply some external force on the object and lift the object from this position to a higher position, let's say right over here, then the potential energy will increase, right?
Yes, sir.
So when motion happens against the system's force, which is W in this case, when motion is happening against the system force, potential energy will increase. When motion is happening by the system's force or in the direction of the system force, the potential energy will decrease. Now what I want you to judge within this figure, the question says a positive charge experiences a force F when placed at a point X in an uniform magnetic field. So I'm copying this image. Let's put it right here. And let's have a look. This is the direction of the given uniform electric fields. It means you can assume that there happens to have a positive charge plate somewhere over here, and there is a negative charge plate somewhere over here. You can imagine this. If you place a positive charge particle over here, and which is positively charged, the force produced on the charge is in the same direction as the electric field lines. So the particle in this case is experiencing the motion. It is going from left to right. This motion moving from left to right, is it happening in the same direction of force, or is it in the opposite direction of the force?
Same direction of the force.
So potential energy should
Decrease.
beautiful.
আচ্ছা স্যার, থ্যাংক ইউ স্যার।
No problem. আরেকটা কোনটা বলছো?
স্যার 8 বলেছিলাম।
Number 8 is a pretty interesting question. Number 8 type of question, I didn't discuss this question because I wanted to pick this up in the MCQ part. The question number 8 is something about levitation or suspension. Levitation or suspension means if we can somehow keep an object floating in a fixed position at zero velocity at rest within an electric field. Have a look. The diagram shows an oil droplet that has become charged by gaining 5 electrons. So it is definitely negatively charged. The droplet remains stationary between charged plates. What is the magnitude and the direction of the electrostatic force on the oil droplet? Try to understand. This oil droplet has some weight. The weight will definitely work vertically downwards. If this oil droplet has to be at equilibrium and at rest in this position, the electric field force must work upwards. And you can see from this figure, this is going to be happening because we have 0 volt over here, we have plus 55 volt over here, which means the electric field of this in between space is going to be working upwards from low potential to high potential. And this negatively charged particle will also experience the force in the more positively towards the direction of the more positively charged plate. Sorry, I'm Bulaxi. Electric field and direction Bulaxi. Electric fields are going to work up to down, high potential to low potential. So the negatively charged particle will be attracted in the upward direction. So the electric field is going to be working upwards, the wood is going to be working downwards. They will balance each other to give us the whole thing of equilibrium. However, the question is asking us what is the magnitude and direction of the electrostatic force on the oil droplet? Electrostatic force must work upwards, not downwards. What is working downwards? Which means B and D are crossed out. Now let's try to do like a bit of a calculation. It says it gained 5 electrons. So 5 electrons gives us how much charge? The Q value would be 5 into E. We know the value of E from the formula sheet. So that will be 5 into 1.6 into 10 to the power minus 19 Coulomb. And then to find out the force, F is given by F equals to QE, or we can write Q into V by D, because here we have a uniform potential, potential difference across parallel plates. So if I place all these values, 5 into 1.6 into 10 to the power minus 19 into 5,000 divided by the distance 0.8 centimeter, which means 0.8 into 10 to the power minus 2. Place everything in the equation in your calculator and find out the number. দেখো কত আসে। What's up?
Sir, 5 times 10 to the power minus 13.
মিলছে?
Yes, sir.
Beautiful. আচ্ছা, আমি আরেকটা কোশ্চেন একটু তোমাদেরকে আলাপ করতে যাচ্ছিলাম because this is important for this chapter. I'm going to jump to question paper 2 and show you one solution of a certain question. So this is going to be here.
Sir, MCQ 21 এর প্রবলেম ছিল।
আচ্ছা, 21 problem দেখতেছি, don't worry. A small charge Q is placed in the electric field at the of a large charge Q. Both charges experiences force F. What is the electric field strength of the charge Q at the position of charge Q? Oh, good question. Let's try to understand the meaning of this question to begin with. I can have it this way. Okay, this way is good. A small charge Q is placed in the electric field of a large charge Q. So let's draw those. Large charge Q, small charge Q. What is the electric field strength of the charge Q at the position of the charge small q? So what is the electric field strength produced by this charge at this location, right here? Irrespective of their sign, if they are oppositely charged, they are going to experience towards force. If they are similarly charged, they are going to experience away force. Let's just consider they are similarly charged. So if this one experiences a force, this one will also experience a force because these two forces are dependent on Newton's third law, action and reaction forces. So you cannot have dissimilar amount of forces onto the two charges. It's very much similar to like the weight that by which Earth pulls me down by Newton's third law, I also pull the Earth upwards by the same amount of force. but Earth's motion is not seen because it has a huge mass in comparison with my mass. That's why my motion is seen, Earth's motion is not seen. Same thing. So the force will be equal for both of them. So I should actually try to draw this arrow a little bit bigger because they're supposed to be nearly equal. Now the question is asking us, what is the electric field strength produced by this charge at this location? So at this location, the field is given by F by Q. And that's it.
So small q কেন নিব কারণ
Because we are trying to measure
ফিল্ডটা
the
তো
bolo.
ক্যাপিটাল কিউ এর তাহলে স্মল কিউ কেন?
Because the force at this position, the force is not experienced by this one. At this position, the force is experienced by this small q charge. The force was exerted by this charge. So the charge that is present at this location is small q. So the diffusion will be calculated using force on unit charge for that location. Vice versa, let me help you to see it better. Vice versa, if the question asked, what is the electric field produced by small q at the position of capital Q? Then that field strength at this location would be F divided by capital Q. These two field strengths can have different values because Q and Q have different values, but they would be same for both of them anyway. এখন বুঝে গেছে কিনা দেখো।
Yes, sir.
The paper 2 question that I was willing to show you is the one that actually handles with the with this one, question number 3. So I'll take this whole question out and we'll try to see. Okay, can I actually make this whole PDF comment? PDF from that list. All pages. Well, we're going to see this one. Hello, Sanka. হ্যাঁ ফার্স্টটা বলছি জি ভালো আছে So let's have a look at this question. Define electric field strength. This is a definition you write. Force per unit charge. Preferably write force per unit positive charge. That's a better definition. Then comes this one. Two parallel plates, metal plates, each of length 12 cm are separated by distance of 1.5 cm as shown in figure 2.1. The space between the plates is a vacuum. The potential difference between the plates is 210 volts. The electric field may be assumed to be uniform in the region between the plates and zero outside this region. So you have to assume a rectangular space within these two plates, actually a cuboid space because it's three-dimensional. You're looking at 2D figure because it's seen from the side. And within this cuboid space, we have an electric field. Outside this cuboid space, there is no electric field. We're assuming it for the sake of simplicity. But in practical cases, outside there is also diminishing electric field because field lines can also come out of this side and enter over here as well in a curved manner like this. However, this is a simplified version, so we are considering that the electric field is exclusively in between the plates and not outside. Okay. Calculate the magnitude of the electric field strength between the plates. It's calculate simple. We have the voltage, we have the distance. So voltage over distance. So if I just write this down over here, E equals to V by D, which gives me 210 divided by 0.015. Correct one. I had to guess it. এটা দেখো কত আসে
Sir, আসছে হচ্ছে গিয়ে 14,000.
হ্যাঁ 14,000 আসবে so I'm going to write 1.4 into 10 to the power 4 I'm going to write in standard form এরপরে আমাদের কোশ্চেনে কি বলছে কি দেখি এখানে বলছে an electron initially travels parallel to the plates along a line midway between the plates so have a look at the figure the electron is coming in আমার জুমের উইন্ডো সব এখানে কেন আচ্ছা I don't need this তোমাদের এখানে কি কিছু ব্লক হইছে না চলে গেছে the electron initially travels parallel to the plates along a line midway between the plates as shown in figure 2.1 the speed of the electron is 5.0 10 to the 7 meter per second for the electron between the plates, determine the magnitude and direction of its acceleration. Well, direction is pretty simple. This is a positive plate, this is zero plate, so it will be attracted more strongly by the positive plate. So the direction is upwards. For the magnitude, we just have to go for some calculation, which I'm about to show you. Have a look. For the electron, F equals to QE, and then again F equals to MA. So the acceleration is going to be given by Q into E divided by M. So now I can try to place all these values. The charge of an electron is 1.6 into 10 to the power minus 19. The diffuse strength was calculated to be 1.4 into 10 to the power 4. Mass of an electron is 9.1 into 10 to the power minus 31. এই সবগুলো ভ্যালু তোমাদের ফর্মুলা শিটে দেওয়া থাকবে। এই ভ্যালুগুলো বসায় দেখো এটা কত আসে। Give me this number in 3SF. বাসা বদলানোর পর কি সাইন্টিফিক ক্যালকুলেটর তৈরি হয়েছে না? That is that.
Sorry, 2.46 into 10 to the power 15 meters per second squared.
Hello, 13.46.
2.46.
2.46 into 10 to the power
15.
50 meter per second square. দেখো তো এটা মিসে কিনা? Someone else confirm this number. কারণ এটা আমাদের পরে হিসাব করা লাগবে. At least 2% confirm this.
Yes, sir. Mile.
Good.
Sir, এটা আমরা কি 3SF রাখবো নাকি 2SF রাখবো?
I personally prefer 3SF all the way. So if you ask me, I'm gonna put I should also put a 0 over here. It was my mistake not to put a 0 over here.
But should we follow the number of significant figures in the question, the values in the question?
You actually can. In that case, what I would
Marks কি তো হবেই থাকে, like যদি question এ 3SF দেয় তাহলে 3SF দেয়, যদি
I totally
question
agree.
2SF থাকে।
One of the things that the reason I prefer to ask the students to write a 3SF number, because whenever you use a calculated number for consecutive calculation, having a 2SF round off and using that number consequently to the next questions, in some cases lead to a pretty significant round of error for the late questions. But if you have 3SF values, you can have a bit of shift in your third SF value, but if you convert those numbers into 2SF numbers, your answers pretty much always matches. Let's say for 99.99% of the cases, the answer will match. That's why I tend to recommend that you should preferably write your answers in 3SF. However, if you want to stick to the mark scheme's SF value, because this is also a 3SF value, and 50 centimeter was 1.5 centimeter is also 2SF value, 12 centimeter is also 2SF value. So everything that is given in this question, they are all given in 2SF numbers. So if you prefer to give the answers in 2SF as well, what I would recommend that you write the 2SF value right over here, but do not forget these numbers over here if you have to use them further on. For example, writing 1.4 over here doesn't make a difference in the calculator. So you better write this 3SF number over here, because if you have to use this number later on, so that you can use the 3SF value, and in this place you can write 2.5.
We can do that. We can like use a different, use an earlier value.
No, they both pretty much.
মানে যদি আমরা এরপরে 2.46 use করতে হয়, if you write 2.5, can we use 2.46?
What I used to recommend it.
Mark scheme ই করবে না যে like you didn't use your answer.
No, never. It is recommended that you should use the least rounded off number for your subsequent calculation. To be honest, if you use your answer value for this whole calculation, the answer that you have, if you can use the answer for subsequent calculation, that's the best. Do you get my point?
Yes, got it. Thank you.
So তুমি এখানে এভাবে লিখলা, 3SF লিখলা at least, আর এখানে তুমি 2SF answer লেখো, I'm good. Direction হচ্ছে in this case upwards. So এটা গেল। এরপর কোশ্চেন নাম্বারটা দেখি। Calculate the time for the electron to travel a horizontal distance equal to the length of the plates. এটা খুব simple. The electron is coming within hold up, I need to zoom out a little bit. The electron is coming in with a horizontal speed of this much. There is a distance of 4 centimeter. So v equals to d by t. So speed equals to distance over time, or distance equals to speed into time. Because this horizontal speed, this will not be affected by the electric field. So you just place these values 1.5, no, 1.5, no, sorry, 5.0 into the power 7 multiplied by 7 to ভুল লিখলাম আমাদের ইকুয়েশনটাকে ভুল হয়েছে
So time to.
sorry d equals to d over b which means this is also 12 centimeters ছিল so this means 0.12 divided by 5.0 into 10 to the power 7 এটা করলে যা আসে
2.40 times 10 to the power minus 9 second.
ওকে আমি এই টাইমটা পাইলাম এই পর্যন্ত ক্যালকুলেশনে প্র্যাকটিক্যালি কোনো ঝামেলা নাই এগুলো খুব সিম্পল this is the question this last question d is what I'm really interested in this is a 3-mark question have a look use your answers in C to determine whether the electron will hit one of the plates or emerge from between the plates use your answer in C to determine whether the electron will hit one of the plates or emerge from between the plates now let me elaborate how to approach this problem in two different ways if I take out this thing and maybe copy and paste it somewhere else too, because I want to work on this. Have a look. The electron is coming in. The electron is coming in, and as the electron will enter, it's gonna start to bend upwards in a parabolic path. The question is, does it hit on the plates or does it emerge out? That's my question. Now, what you need to understand that if the electron has to emerge out, whenever it covers a 12 centimeter horizontal distance, it should cover less than this distance, right? How much is this distance? It will cover
0.75 centimeters.
0.7. So the logic is, by the time it covers 12 centimeter of horizontal distance, it should cover less than 0.75 centimeter of vertical distance. If that happens, then it is gonna be coming out. If it covers more than that, then it would mean that the electron has already hit this plate somewhere over here. It actually could not come out of the plates because if the possible calculated value is more than 0.75. So one thing that we can do is we can calculate how far is the vertical distance covered by this electron for that time that we just calculated. How much time did we calculate? Right over here, we calculated 2.40 into 10 to the power minus 9 centimeters a second. So what is the vertical distance covered by this thing? We have to calculate this. Now let's go for the vertical equation. So we know that for the projectile motion h equals to uy t plus half ay t squared. Recall this equation, anyone?
Yes, sir.
Looks familiar? It should. So in this case, I'm going to write h equals to 0 into t because initially the particle electron did not have any vertical speed plus half into acceleration. We calculated that. I'm going to write 2.46 into 10 to the power 15 multiplied by 2.40 10 to the power minus 9 whole squared. So that's the equation that I have. You could actually forget this mark. Can I actually delete this mark? Delete this line. Is there a way that I can delete this line? No, I cannot. It pairs up weirdly the other stuffs. Forget, disregard that line. So এটা ক্যালকুলেট করে দেখো হিসাবগুলো কত আসে everyone. Help me to do this calculation. এটা কতটুকু আসে দেখো.
7.1 10 to the minus 3.
7.1 into 10 to the power
Minus 3.
minus 3, which means it becomes about 7.1 centimeter. No, 0.71 centimeter. 0.71 centimeter. Second, 0.71 centimeter. So it means within this covering of this horizontal spacing, this electron is going to rise up to 0.71 centimeter. But the allocated space was 0.75. Now you have to show this calculation. You have to write. This is how I would write if I was answering this. Available vertical height to emerge out equals to 1.5 divided by 2 equals to 0.75 centimeter. So, no. Because electron rises less vertical height than 0.75 centimeter, it emerges out. I'm going to write all this stuff in words. Or you could also write, if you don't want to write this in words, you could also write h less than 0.75 centimeter, so emerges out. এটা লিখতে হবে, সমস্যা নেই।
স্যার
বলো।
স্যার ফার্স্ট পার্টে আপনি ওই যে 0.75 এর কথাটা বললেন না যে এইটুক ভার্টিক্যাল ডিস্টেন্স ট্রাভেল করলে কি হবে কি না হবে ওই পার্টটা বুঝুন।
এখানে আমার the space between the two plates was 1.5 centimeter. The electron is incoming over here at a certain speed, right? Now, if the electron has to come out of this electric field, it has to go out of this two plate boundary. I mean, when it covers 2 centimeter, it cannot go more than 0.75 centimeter. How much space, how much vertical space does it have available while it covers 2 centimeter if it wants to go out? What is the maximum amount of vertical height that it can gain? Theoretically, it's 0.75 centimeter. If it goes exactly at 0.75 centimeter, it's gonna, let's say, rub off the edge, but still gonna come out. If it goes less than 0.75 centimeter, which means what? I mean, if I draw with a much bigger zoom view, if this particle, if this electron was covering exactly 0.75 centimeter when it covers, when it covers 2 centimeter of space, the path of this electron might as well look like this. It's gonna come in through here, just slightly rub off the edge and eventually come out straight line. You need to see that this part is a curve, but as it comes out of the electric field, this is going to be straight line because there's no electric field over here. So this motion should be uniform velocity. However, this motion is under force. This is going to happen. But if the electron covers a bit less distance, then it can very conveniently come out of this electric field in a path like this. Bad mistake. The electron can very easily come out of this plate like that, or maybe like that. It's not going to hit the plate. But if it's supposed to cover more than this, which means if the calculation tells us that whenever it comes at this point, the particle is going to cover more than 0.75, which means that possible trajectory for this particle was supposed to be like this, let's say. It's going to be like that. Now, this is not going to happen because if to achieve this one, hypothetically, before it reaches at this point, it is going to hit one of the plates, right?
Yes, sir.
So, we are checking that how much would the vertical space distance covered as the particle covers a horizontal distance of 2 centimeter. So that's all that is.
So sir, যদি 0.57 থেকে বেশি হতো তাহলে we would have said যে মানে the particle or the electrons that hit one of the plates.
Upper plate.
Yes.
এই প্রবলেমটা সলভ সবার বুঝে গেছে? কারো কোনো কনফিউশন? Anyone? আচ্ছা, ফায়াজ, মাঝখানে তুমি আমাকে একটু ডাক দিছিলা, আমি তখন 5 মিনিট লিখছিলাম, তুমি কি যেন একটা প্রবলেম বলতে চাইছিলা?
না স্যার, থাকুক, কিছু না।
বুঝছো?
জি স্যার।
আচ্ছা, পরে বুঝলে সমস্যা নাই। ওকে, গুড. I'm gonna stop the class for today at this point. I would like all of you to attend this electric field worksheet. এটা তোমাদের মনে ফার্স্ট সেট অফ টেস্টটা মনে হয় নাই, আই এম নট শিওর, বাট এটা অ্যাটেন্ড করো। এমসিকিউটা শেষ করবা, এমসিকিউটা শেষ করে পিটুটা অ্যাটেন্ড করবা। পিটুতে যা যা প্রবলেম হয় ইনশাআল্লাহ আমরা নেক্সট দিন দেখবো। আমাদের নেক্সট ক্লাস হচ্ছে কবে? বৃহস্পতিবার না? মানে কালকে তো?
Yes, sir.
হ্যাঁ, কালকে ইনশাআল্লাহ এই পেপার 2 এর প্রবলেমগুলো নিয়ে আমরা আলাপ করব। আর পেপার 1 এ যদি তোমাদের কোনো ফার্দার প্রবলেম বের হয় সেগুলো আলাপ করব। থ্যাংক ইউ। আল্লাহ হাফেজ।
আল্লাহ হাফেজ স্যার।